Hello and welcome to Easy Classroom. For today, we will be learning sequential circuits. Now, what are sequential circuits? These are the basic combinational circuits that we are actually adding some special elements to actually make it a special circuit. Now, what is this special circuit? It is just we are actually adding a memory block to this system so that we can actually store whatever the previous outputs or the machine states that we are actually experiencing. So let's get started. So here it is, as we are mentioning, it is a combinational circuit and we are adding a memory element to it to get this sequential circuit done. Now, how it is a combinational circuit? Because in the combinational circuit example or in the combinational circuit definition, what we have learned it depends only on the present input. Here in this circuit, we can see that it also has this feature that the sequential circuit are a kind of circuits that accepts some input as present input. So it depends only on present input, the combinational circuit ones, and depending on the present input and the previous output of the circuit. The previous output, what we mean by the previous output, it is just the output that is here, and if we can store this output into some memory block, then that is previous output. Okay, this is the previous output and this is a memory block that where we can store this previous output. Okay, or the internal state of the circuit before the input was applied. The same thing, the internal state could be stored in somewhere and it can be reused. Okay, so this is something that we actually gonna need. So this is something, so this is known as feedback. Okay, so this feedback input will be applied with this present input to get our desired output. So this is how our sequential circuit works. So here also it produces some output. So it depends on present input and the previous output to give us the output. Okay, the next output obviously. So here I have mentioned that to hold this previous output state we need some memory block, and with that we can give this feedback, and this is known as feedback, and it will be applied to this with this present input to get the output or the next state of the output. Okay, now the key points that here we can discuss is the same thing that we have discussed earlier. It is a combinational circuit with a memory element. We have learned that it uses feedback, so it is actually using feedback, and it is complex design. Obviously it is complex design because we have to incorporate this memory element and sync it or non-sync it with our present inputs to get our outputs. So these are the basic things that we need to understand before we can go on further in sequential circuits. Okay, so we can have these examples, that is latch, flip-flops, registers, counters, and many more. Okay, so our basic sequential circuits are of generally two types. One is synchronous sequential circuit, that is non-synchronous or asynchronous sequential circuits. Now what happens in synchronous and what happens in asynchronous? Now if we can understand these two things very clearly, we can develop anything or any circuit depending on this knowledge. So in synchronous circuit, what we are actually synchronizing, we are synchronizing inputs as well as outputs with a special kind of select input or control input. Okay, in combinational circuit, what we have learned there are select inputs, there are the control inputs. Here we are actually giving a special kind of control input, and with that we are synchronizing these inputs or outputs. Okay, here in this we don't have to synchronize these kind of things, as we don't have as such kind of things. So for synchronizing these have some delay in operation, as we know that with synchronizing it can be very difficult to actually incorporate everything and synchronize those things into parts. So it is generally a slower process, whereas it doesn't have any synchronizing techniques, so it is much faster. It is kind of what we say difficult to organize and difficult to design. For that matter, it is not so difficult to design. Okay, so these are the things that we need to understand before we can actually go on to these things. I can write those things. Now, what are these spatial controls? These spatial controls we say are nothing but system clock pulse. Okay, these spatial inputs or these spatial things are the system clock pulse or system clocks. Now, why we do these things? So let us example, since we are actually reading this digital electronics, so we know any signal that we pass is of square wave, right? So this is what we known as a clock pulse. Okay, or clock signal, you can say anything, right? So depending on this clock pulse, we can have 2 or 3 different kind of circuits in synchronous and in asynchronous. Okay, now depending on this clock pulse, we can have triggering techniques which actually triggers when to give the outputs or not, or when not to give outputs. Okay, so these are very few subtle things that we need to actually know to go on with these kind of sequential circuits. So these are the triggering techniques that we can use okay. These triggering techniques can be of 2 types. Okay, one is what we say as phase or state, okay, and another is edge. Now what we say phase or state, say for example this is our clock pulse, okay, and from here to here, this is from here to here, this is one clock cycle, one cycle, right? So now what happens, this phase or state can be said as this entire thing, this is 0 and this is 1, right? So this is 0, this is 1, and this is 0, this is 1, 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 and this is 0, right? So now what happens, we can have this as 0 state, or we can have this as 1 state or phase. So here we can say, depending on where our clock phase is, we can actually trigger our circuit, right? So to trigger our circuit, we can design these phase techniques. So phase will be detected and corresponding outputs or inputs will be conducted, right? So these phase are very, very important in our system. So now we have known that these are the phases. So if we can say this is 0 state or 0 phase, this is 1 state or 1 phase. Okay, now coming back to this edge. Now what is edge? Now here if you can see, so these are states. So here if you can see, we are now right now, say for example at 0, right? And so if we're gonna climb up to 1, so this entire thing is an edge. And if we are stay, for example over here, and if we want to go down, so this is another edge. So we say this is rising edge and this is falling edge. Okay, now this rising edge and falling edge, in technically we have these two edges, right? So in technical terms we can say this is positive edge and this is negative edge. So we have two triggering techniques for edge, and there is one triggering technique for this phase. And we can say technically we have two triggering techniques for phase also, but still we have this triggering technique, two triggering technique for edge. One is positive, then where we are actually climbing from 0 to 1, and then there is a negative where we are climbing down from 1 to 0. Okay, now there are some nomenclatures that we gonna learn as to how to detect these triggering techniques in our circuits or block diagrams. So we are going for phase age or levels. Okay, we can say level also. So if we can say, so here we are going for the levels. So in this thing, if we want to design a positive level phase or state circuit, we're gonna simply draw like this. So these are the outputs. This is a control signal or clock, whatever we can say, and this is our outputs. Okay, for now we can say these are some inputs and these are some outputs. So we can say this is positive level. Now for the negative level, what we are going to achieve, we are doing like this. So this is S, this is R, this is Qn, and this is Qn complement. So these are the outputs. And if we have bubble over here, that is we have not yet in our our combinational circuit. So this we can say with just a bubble, we can say this is negative level triggered. Okay, so for the edge, if we design the same thing, same logic circuit, same block diagram with some, so this is S, this is R, this is Qn, and this is Qn complement. Okay, so now if we design like this, okay, if we design like this, we can say this is positive edge triggered, and if we design like this, so if we design like this, then we can say this is negative edge triggered circuit. So by this applying this not, we are saying this is not from the combinational circuit. Same thing happens over here also. We are actually using this not thing to actually get over our circuits. Okay, now for the purpose of the sequential circuit, what we have learned earlier, we have learned this, we have to incorporate a memory element. Now, what is memory element? A memory element is such where the output or the state of that circuit does not changes for whatever reason of the input. Okay, so the memory element could be of many states. It can be a single state memory element, it can be bi-state memory element, and so on. Okay, so the bistable or bi-state memory element where we have two states, 0 and another is 1. Okay, now what happens, what we now if we can design this memory element, the simplest memory element that we can find using NOT gate is a cascading NOT gate. Now what happens? So if we gonna add this, so whatever is happening, if we can cascade this thing, so the output will be this and the output will be the same. So the output, input and output is the same. So whatever we give, it does not changes its state. Okay, so this can be a single state or single stable circuit. Now if we gonna take it further, what we can do, we can use OR gate to actually create that thing. Say for example, we have a circuit where, say for example, we have a circuit OR gate with A. And we are actually feeding that to a OR gate, right? And the output of this OR gate is actually redirected to this particular circuit. Okay, so now depending on the previous output or depending on the previous state of this OR gate, we gonna determine what is our next state or output, next output of this circuit. So say for example, if we have 1 over here, okay, I'm clearly mentioning if we have A as 1 over here, and say for example Qn is 0 or the previous output, okay, the previous output is 0. So whatever the thing that will happen, the output will always be Qn plus 1 is always be 1. Okay, now the same scenario, if Qn is 1 or the previous output, previous internal state is 1, so whatever happens, the output for the next state, the output of the fresh output will be always 1. So we can understand just by applying and just by managing the previous state, we can have a stable state in both the scenario. Okay, now if we have something like this, then things go pretty easy, right? So if we have 0 as here, and depending on the previous output, we are getting the next output as 0. Okay, but here what will happen, we are getting 1. So these are not these two outputs are contradictory to each other, and we cannot apply these kind of things. So by using OR gate, one thing has to be clear, that is the one input should always be at high state, and then only we can create this kind of memory system. Okay, for further memory systems, for further stable systems, we are actually using latches. Okay, for the next class, what we will be doing, we will be creating latches, flip-flops, counters, registers, and so on. So for the first few things, what we will do, we will actually explore the latch purpose and then the flip-flops. Okay, I hope you have understood this thing. If you have understood, please do like, share and subscribe. Thank you.